Hi, Daricus. It was great to meet you online and to talk about some of the material in Chapter 1 that you had questions about. I just wanted to take a moment and talk through some of the homework questions. You got all the homework questions right, so I'm thinking you know how to get the answers, but you're feeling a little unsure. So we'll just talk through this briefly. The first question that we come across deals with statistic versus parameter. And so really the key that you're looking for is, think about your population and ask yourself, is the numerical measurement that I'm gathering, is that taking into account all the members of the population or just a subset of the population? So for this particular problem, it says that we're going to study all the professors at a college. So that's the entire population. If you're dealing with a population, the statistic is called a parameter. So parameter goes with population, okay? That's the first one. Okay, the second problem deals with a homeowner and the voltage. I think this is what you were talking about in our conversation, maybe with the energy. But at any rate, it says that the homeowner measured the voltage supplied to his home on a random sample of 45 days. So because you're only sampling 45 days, then you aren't taking every day into account. So you are taking a sample, all right? When you take a sample, then the data that you collect would be called a statistic, okay? So a parameter for a population, a statistic is relevant for a sample. So it's kind of just remember statistic and sample, they both start with S. Parameter and population both start with P. Okay, so the other thing that and here's another one. All right, so here we have a particular country with 55 states. If areas of all 55 states are added, so notice that we're taking all of the states. If we were just dealing with 2 or 3 or 50 of them, then it would be a statistic. But because we are collecting data, the areas from all 55, we know that we're dealing with the entire population, and here the measurement would be a parameter. So parameter goes with population. Okay, and so the next problem that we come across is this one. So dealing with the levels of measurement, we talked briefly about this when we spoke, but we'll work through these examples. So the first one, determine which of the 4 levels of measurement is most appropriate. So here the problem is posing favorite musicians, okay? And so because the musicians, right, are a discrete list, right, then they are names of people, and so they are in name only. We can't put them in any given order, right, any meaningful order. It's just, a list, a listing. So that would be nominal. Okay, the next problem, the example we're given is class times measured in minutes. Okay, so with this, we know that we're dealing with the numerical measurement, that differences do matter, right? So when we're dealing with minutes, as we are here, we know that we're dealing with ratio data, because there is a natural 0, right? So in other words, you can have 0 minutes. That's your base, right? You can't dip below 0 minutes. So you can have 0 minutes, 1 minute, 2 minutes, right? So it has a natural 0. There's a natural starting of 0. You can't have a negative 1 minute, right? So with ratio, there is a 0. There's an absence of. All right, so we can't have negative minutes. Okay, so here's another example of ratio. We're dealing with acres of land. right? You can have 0 acres of land, 1 acre, 1.5, and so on, but you can't have any negative number of acres. So because there's no negative, right, it starts at 0, it has a starting point, then we're dealing with the ratio level of measurement. Again, because there is a 0 starting point. Okay, moving along here, we have the number of houses that people own, okay, and just kind of thinking about that like we did the last couple of problems, people can own no houses. They can own 1 house, 2 house, etc. But there's no such thing as owning a -1 number of houses, right? So, therefore, we are at the ratio level of measurement because there is a natural 0. Okay, you can't have any negatives. It starts at 0 and goes up from there. Okay, so now we come to the next example, and we're talking about the years in which a recession occurred. All right, now when we're talking about years, there is no natural 0, right? Because we have, time is on a continuum. We have, as we're moving, right, into the future, we have, an unknown number of years before us, right? So there's no 0. There's no natural starting point, right? So time started at some point, but it has no natural starting 0 that we can quantify. So whenever you're dealing with time, just kind of pause and ask yourself, am I dealing with the years, right? The actual years themselves. If you're dealing with the years, then you're dealing with the interval level of measurement, okay? All right, in this next example, we have alert levels that are represented as 100, 200, 300, okay? And so the mean was calculated. Now, because we have a low, medium, and high, those are like ratings, okay? Ratings are ordinal, always, okay? So because those numbers have can be put in order, right? 100 to 300, they can be put in order, but the differences between them are not clearly identified, and so therefore it can't be interval, okay? Because even though we can take the numerical difference between like 300 and 100, it still doesn't give us a meaningful difference. There's a numerical difference, but it's not one that is really meaningful. Okay, so that's the problems that I've kind of pulled to talk through. I hope I haven't confused you more. Maybe this has helped somewhat. But if you have any other questions, feel free to reach out.